Hi, my name is Darshan. I'm the product manager for the automotive solution. Today I'm very excited to introduce you a new solution for automotive Ethernet called signal separation. As you know, automotive Ethernet is a full duplex communication, which means that master and a slave can send the data simultaneously on the same link. And in this, when you probe on the any of the node, whether on the master or a slave side, the signals are overlaid. So you may not be able to do any signal analysis or a protocol decode before doing a signal separation. Now, one of the solution available in the market is using a directional coupler. There are two main challenges with the directional coupler based approach. The first one is that it has an SMA connectivity. So to install directional coupler in the system level, you have to cut the automotive Ethernet cable and then connect the directional coupler. The second one is that it has its own insertion loss and the return loss. So which means that your overall system performance will be impacted because of the directional coupler. So Tektronix has come up with a very innovative solution where without cutting any cables or impacting or loading the ECUs, we can do a signal separation in the software. So in this setup, we have the two ECUs communicating in a full duplex mode using an automotive Ethernet cable, and we have the automotive Ethernet 5 chips connected, which is 100 base T1, and we have connected a voltage probe and a current probe on the master node to perform the signal separation. So let's go into the demo to see how we are doing the signal separation here. As we saw in the setup diagram, we have connected a differential probe on the channel 1 and the current probe on the channel 2. So the channel 1 is the differential voltage signal. This is a full duplex signal. As you can clearly see in this waveform that it's not a PAM3 signal. It is a multiple level signal, and if we try to perform any analysis or a protocol decode in this waveform, we may not get anything because it's a full duplex overlapped signal. So what we are going to do is that using this completely automated TechExpress solution, we are going to perform the signal separation. So in this case, it's a full duplex signaling. We are using a single voltage probe and a current probe. And when you perform this signal validation, it performs the signal separation in the software using Tektronix proprietary algorithm to separate the signal. In this case, we are not going to run this, but I'll show you that once the signal separation is done, we will get the waveform loaded into the reference signal. In this case, it is on the reference 7 and the reference 8. So you can see that the reference 7 signal is after the separation. So this is the near end master signal. Now you can clearly see it's a PAM3 signal. It's a 3-level signal and shows the a separated signal for the master. And the R8 is the far end signal which is from coming from the slave side. You may see some ringing effect on the slave signal compared to master signal because it has the cable effect as well. Now let's perform the protocol decode and see whether we are able to decode this bus or not. So in this case, we are going to configure the protocol decode in this case. So let's try to turn on the bus. Okay, we can see clearly automotive Ethernet protocol decode with all the frame structure. It's IPv4 packet types, and we see a data bytes here. So let's look at the result table for the protocol decode. So you can see all the different field here. So you have the MAC ID and the IP data also in this. So it is able to decode on the R7. So we are decoding on the master side. Similarly, we can decode on the slave and do a protocol decode of both master and a slave signal without doing any cutting the cables or adding any directional coupler in this. Now let's move to the next step, which is the PAM3 eye diagram analysis. So in this case, these are all different measurements we support for the signal separation. One of the very important thing to note here is that the voltage level of the separated signal. Unlike directional coupler, here you get approximately around 900 millivolts to 1000 millivolts of peak-to-peak signal for both master as well as the slave signal. So next step is we are going to perform some of the analysis for the master as well as the slave signal, and we support eye diagram, the jitter measurements like the total jitter, rise time, fall time, and the linearity measurements. So again, we are not going to run all this test, but we have already ran this test. In this case, this is the summary of the table. In this, we have defined user defined limits, so user can add all the limits here in the configuration panel. We have the user we have a editor to define and add the result here, sorry, the limits here, and then you can see the limits, so it will show you the measured value against those limits. We can also see the complete report of these measurements, which gives you, we make it 100% so that we have a better visibility. So it gives you the scope model number, all the measurements it has performed. It gives you the limit and whether it is pass or a fail against those limits. It also gives you the plot for both. Here is an eye diagram plot for the near end. This is the eye diagram for the slave part. And similarly, it gives you a bathtub curve plot that at what BR level the eye is closed for both upper eye and the lower eye, and again both for the master and the slave. So in summary, you can see the eye diagram as well as the protocol decode using in the single window to perform the signal separation and the protocol decode. So in summary, there are three main advantages of this solution. One is this solution gives you a real signal view without impacting on the system. In this case, we are not cutting the cable to install a directional coupler or convert the automotive Ethernet cable to SMA cable to separate the traffic. So it gives you a true picture of the signal going from master to the slave. It is very easy to set up because it's just connecting a voltage probe and the current probe in this case. It gives you a view of protocol as well as the physical layer signal in a single window, which helps us to debug faster for any validation issues or any functional issue if you want to validate. And this solution can be used starting from the design stage all the way inside the car for any debug or the protocol validation as well as for the signal analysis.